Okay, number one, y equals 2x plus 4 and y equals 3x plus 7. Well, we've already described y in terms of x both times, so all we need to do is substitute one expression in for y in the other equation. So I'm going to take 3x plus 7, and since y equals that, I'm going to plug it in to y right there. So I'm going to rewrite this equation as 3x plus 7 equals 2x plus 4. And then I'm going to subtract 2x from both sides. 3x minus 2x plus 7 equals 2x minus 2x plus 4. Those two cancel, and I'm left with 3x minus 2x is just x plus 7 equals 4. And then I'm just going to subtract 7 from both sides, and that gives me x equals 4 minus 7 is negative 3. So when x equals negative 3, what is y? Let's look at this first equation. 2 times negative 3 is negative 6, and then when you add 4 to negative 6, you get a negative 2. So when x is negative 3, y is negative 2 in this first equation. And then when you multiply 3 by negative 3, you get negative 9. And then when you add 7 to that, you get, indeed, negative 2. So when x equals negative 3, y equals negative 2. And so our solution is that. And I told you, when you're dealing with linear equations that are meant to be graphed, you should always write the solution in the form of an ordered pair. So x and y, this could also look like when x is negative 3, y is negative 2. And there we go. That's our solution. I will say, on some of your papers, I've been seeing some of you solve for one variable. Let's say x equals negative 3, and you're assuming that you found the right answer and you don't tell me what y equals or what the other variable equals. Make sure that you don't do that. If I'm asking for a solution, I'm asking for the value of both variables. Number 2. Okay, this one's a little harder since we first have to describe one variable in terms of another. I'm going to take this equation and I'm going to describe x in terms of y. So x minus 2y equals 4. Again, I can't stress enough that this is not the only way to do this. I'm going to add 2y to both sides, so I get x equals positive 2y and positive 4. So I got 2y plus 4, x equals 2y plus 4. So when I rewrite this equation, I'm going to substitute something in for x. I'm going to add 2y, and that equals 8. What does x equal? X equals 2y plus 4. I've got parentheses. Do I distribute? Technically, there's like an invisible 1 there, and 1 times anything is itself. So you just, since it's positive, everything's just going to stay the same. So 2y plus 4 plus 2y equals 8. Nothing changes. I'm going to combine my like terms. I'm left with 4y plus 4 equals 8. I'm going to subtract 4 from both sides, and I am left with 4y equals 4. And so it's not hard to see that y equals 1. Now, when y equals 1, what must x be? So in more complex equations, you would solve for x, but since these equations are pretty simple, I'm not going to go through the trouble because I don't have the space. So 2 times when y is 1, that's just going to be 2. What plus 2 equals 8? Well, that's 6. So x is going to be 6 in this equation. And then something minus 2 times 1. So what minus 2 equals 4? Well, 6. So when x is 6, y is 1. When y is 1, x must be 6. Our solution is right here. And it's also written like this. Number 3. 3x plus y equals 13, and negative 9x minus 3y equals negative 39. I'm going to choose to describe y in terms of x using this equation because y is by itself. That's 3x plus y equals 13. If I subtract 3x from both sides, I get y equals 13 minus 3x. And reviewing what we went over or reviewed the other day, if I wanted to turn these around and put it into proper slope-intercept form, I'd take the second term, the term with the variable x, and its coefficient -3, and I'd put it first, and I'd put the positive 13 second. So that would be y equals -3x and then a positive 13. There we go. And now I know that y equals -3x plus 13. So I can take this second equation and fill it in. -9x minus 3 times whatever y equals -39. And what does y equal? We know that y equals -3x plus 13. So we will rewrite this -9x, and we're going to distribute properly, which means we take the number outside, which is -3, and we distribute it to both terms. Some of you are still forgetting to distribute to both terms. -3 times -3x is positive 9x. Ding, ding, ding. Sirens should be going off in your mind right now. Something's different or odd about this particular equation. And then -3 times positive 13 is, that's 1326, that's -39, equals -39. Again, ding, 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 bells should be going off. What's going on here? Something's weird. -9x plus 9x is our favorite number, 0. And then 0 minus 39 is 39. That makes sense. And so at this point, it should be fairly clear we don't have a variable. But let's finish it off. Let's add 39 to both sides, and we get 0 equals 0. Well, what does that mean? How many solutions are there to this particular problem? There are an infinite amount of solutions, which means these are the same line. They must be. Well, if they were the same line the whole time, then we could have solved this a lot easier. So if there's an infinite amount of solutions, first of all, that's the answer. So if you're having trouble on the test and you can't find a solution, well, I shouldn't say that, but be wary of infinite solutions. Now, there's probably an easier way to find the fact that these are infinite solutions. And the easiest way is to put both equations in slope-intercept form, because it's very easy to see that they're the same line when you do that. Because if you solve for y, they're going to be the same line. And let's do that now. We know that the first equation is y equals -3x plus 13. The second equation, this would be, let me do this here, -9x minus 3y equals -39. Add 9x to both sides, and you get -3y equals positive 9x minus 39. And then you are going to divide by -3. Divide by -3, divide by -3, and you get y equals 9 over -3 is -3x, and -39 divided by -3 is positive 13. And, ta-da, you've got this line, y equals -3x plus 13, working with the same line, and so there are an infinite amount of solutions. However, what you also could have done is you could have noticed something about these two equations. Did anyone notice this? If this is 3x plus y equals 13, and this is 9x, look at the 9 and the 3, and this is -9x, and this is -3y, look at the y, and then this is -39, and look at the 13, then all we did is we took this equation and we multiplied every single coefficient and this numeric term by what? -3, right? 3 times -3 is -9. Y times -3 is -3, and 13 times -3 is -39. So that's an easier way. If you notice that, then you can avoid doing all of this work, and I'm sure you want to do that. So, number 4. Let's find our solution. Okay, y equals negative 3x plus 2. We already have a term we've already described y in terms of x. So I'm going to rewrite the second equation. Negative 2 times whatever y is equals 6x minus 14. And we know that y is negative 3x plus 2. And we're going to distribute negative 2 times negative 3x is 6x. And then negative 2 times positive 2 is negative 4. Uh-oh. Another bell should be going off. All right, then let's isolate our variable. I'm sure at this point I don't need to go step by step. I'm going to subtract 6x from both sides. So although I'm breaking my cardinal rule, don't do this. I should have rewritten it, but I'm saving time. 6x minus 6x and 6x minus 6x gets rid of the 6x's, and I've got negative 4, or I'm left with negative 4 equals negative 14, which is not true. This is a false statement. Which means what about these two systems of inequalities? Or not really. What does that mean about this equation right here? What's the solution? There is no solution. If there is no solution, then that means when we're working with a system of equalities, a system of equations, we are dealing with what? There's only one situation where there is no solution. And what is that? Let's explore. All right. Every set of lines, there's only 3 situations when you've got 2 lines. All right, there are 2 lines that do not have the same slope, which means eventually they're going to intersect, so they have one solution. There's 2 lines that are the same line, so there's one line and there's the other. They have the same slope, but they're also the same line, and so those have, I should say, one solution. These have infinite solutions. Infinite solutions. And then we've got the last possibility. 2 lines that have the same slope, but that are not the same line, which means they're never going to intersect, and so those have no solutions, or no solution. And if you solve for y here, let's solve for y, which means we're going to divide both sides by negative 2. We are left with, where should I write this? I'll write it over here. Negative 2 over negative 2 is 1, so we're left with y. Negative 6 over negative 2 is negative 3x. And negative 14 over negative 2 is just positive 7. But that doesn't matter, because we're left with 2 equations that have, although they're not the same line, that's positive 2. They're not the same line, but they do have the same slope. This is sloping downwards, down 3 units for every 1 unit forward, down 3 units for every 1 unit forward. And so they're parallel lines. There is no solution to this. And you are going to have an infinite solution and a no solution question on your test. So be on the lookout for that. And just to review, when you have infinite solutions, you get an answer of 0 equals 0 or x equals x. I should have mentioned that. You could end up with 0 equals 0 or x equals x. Either shows you or indicates infinite solutions. And if you get a statement that's not true, like 4 equals 2, or 2 equals negative infinity. We haven't talked about that yet. 2 equals 8. Those are not true statements. Those are untrue statements. They're false, so there's no solution. All right, number 5. 2 small pitchers and 1 large pitcher can hold 8 cups of water. 1 large pitcher minus 1 small pitcher constitutes 2 cups of water. How many cups of water can each pitcher hold? Well, what are our variables here? Well, we've got the number of cups in a small pitcher and the number of cups in a large pitcher. And that's what we want to find out. So let's describe the number of cups in terms of S and L. We know that the 2 small pitchers holds 2 times the number of cups in a small pitcher, and 1 large pitcher contains 1 time the number of cups in a large pitcher. And that gives us 8 cups. We also know that the number of cups in a large pitcher minus the number of cups in a small pitcher constitutes 2 cups. So the number of cups in a large pitcher minus the number of cups in a small equals 2 cups. And now we just have to solve this system of equations. I'm going to choose to describe L in terms of S, so I'm going to add S to both sides, and I get L equals 2 plus S. Now I know what L equals. I can substitute L in for L in this equation. 2S plus, and what does L equal? 2 plus S, and that equals 8. Now I'm going to distribute this invisible positive 1 when you've got a positive or an addition sign before parentheses. You don't really need to change anything. Nothing changes. So plus 1 times 2 is 2, and 1 times S is S, and that equals 8. Combine my terms and I get 3S plus 2 equals 8, and so 3S equals 6 and S equals 2. So we know that the number of cups in a small pitcher is 2. So how many cups do we have in a large pitcher? Well, doesn't matter. We can take either equation and solve for L. 2 times 2 is 4. 4 plus what is 8? We know that L must be 4 cups. And let's double check it in our second equation. L minus S, or 4 minus 2, is indeed 2. So we know that we have come across the right answer. There are 2 cups in a small pitcher and 4 cups in a large pitcher. Number 6. A test has 20 questions worth 100 points. The test consists of true-false questions worth 3 points each and multiple-choice questions worth 11 points each. How many multiple-choice questions are there on the test? Okay, what are our variables? We want to know the test constitutes of true and false questions worth 3 points each and multiple choice questions worth 11 points each. So we've got 2 kinds of questions. True and false, let's call that, I don't know, let's call that F, because a T looks like a plus sign. And multiple choice questions worth 11 points each, let's call those M. So how many true-false questions do we have? How many multiple choice questions do we have? So F stands for the number of true-false, and M stands for the number of multiple choice. So a test has 20 questions. Well, the number of true and false questions plus the number of multiple choice questions equals 20 questions. And we also know that each true and false question is worth 3 points. Now you add that to the number of points that each multiple choice question gets, which is 11, and that's a total of 100 points. And ta-da, we have our system of equations. Now we just have to describe one variable in terms of another and solve. So I'm going to describe M in terms of F. M equals, let's write this up here, M equals 20 minus F. 20 minus F. And we're going to substitute that in this equation. 3F plus 11 times 20 minus F equals 100. And that gives us 3F plus 11 times 20 is 220 minus 11. 11F equals 100. And I'm going to subtract 220 from both sides, so I'm left with 3F minus 11F equals, let's see, that's negative 120. And then 3F minus 11F is 8F. Negative 8F equals negative 120. And then 120, or negative 120, divided by negative 8 gives us F equals 15. So there are 15 true and false questions, and that leaves us with 5 multiple choice questions. Simple enough. And I didn't explain how I got that, but by now you should know you just plug in 15 for f, 15 plus something equals 20, and that's something if 15 plus 5 equals 20. Plug those into f and m here, and you should get 100. Okay, number 7. Write the equation for the line that passes through the points 10, negative 38, and negative 10, 42. That's fine. In order to write an equation, I need a value for m and a value for b. So how do I find m? M equals the change in y over the change in x, which we know is y2 minus y1 over x2 minus x1. And that equals y2 is 42 minus negative 38, and that's over negative 10 minus 10. So what is 42 minus negative 38? That is positive 80. And negative 10 minus 10 is negative 20. And 80 divided by negative 20 is negative 4. So we know that m equals negative 4. M equals negative 4. Now, in order to find b, we need a value for x and y, and we've got that. Let's use, oh, it doesn't matter. Let's use this for our x and that for our y. So when y is negative 38, then the slope, negative 4, times the value of x, 10, plus something, b, is going to be negative 38. So simplify this. Negative 38 equals negative 40 plus b. And what is negative 40 plus what is negative 38? It's not hard to see that b is positive 2, or just 2. So now we have the equation of our line. Y equals negative 4x plus 2. We know that our y-intercept is 2, or written when x is 0, y is 2. And our x-intercept, oh, I shouldn't have written it like this. Y does not equal 2. Y-intercept, I'll put a little colon here, equals 2. And x, when x is 0, y is 2. And our x-intercept is, let's see, let's solve for x. 0 equals negative 4x plus 2. Subtract 2 from both sides, we get negative 2 equals negative 4x. So x equals negative 2 over negative 4, which is 1/2. So our x-intercept is 1/2, which means when x is 1/2, then y is 0. And now we can plot our, or we can graph our line. Let's plot our points. When x is 0, y is 2. And when x is 1/2, y is 0. So it's about like that. However, we don't really need this. A better way probably would be to find an actual point rather than guesstimating. So we know that the slope is negative 4x. So that means we go down 4, 1, 2, 3, 4, and over 1. Or we could go up 4, 1, 2, 3, 4, and back 1. And all of those points should lie on the same line. And ta-da! I'm on a computer, so don't judge my line. There's a, oh God. All right, let me try and do a better job. I don't have a straight edge. There we go. That's a little better. And there's our line right there. Your line should look something like that. Actually, it should look better than that. So, the 3 parts to this problem, and it's going to be a 3-part problem worth 3 times as much as all the other problems, so you better learn how to do it. I should say you better remember how to do it, because we spent a month and a half in January and February learning this. The equation of our line is y equals negative 4x plus 2. Our x and y intercepts are here, and our line looks like this. These are the 3 parts. You should be able to do all 3 of these. Number 8, graph the inequality. Don't we love inequalities? Well, this one's simple. It's already in slope-intercept form. What is our y-intercept? Well, when x is 0, y is 1. And we have our slope, so we can find the next point. The next point is 2 up and 1 over. 1, 2, and 1 over. The next point before that is 1 down 2 and 1 back. And we can keep on doing this if we want more points. 1, 2, 1 over. 1, 2, 1 over. And down to 1, 2, 1 back. Down 2, 1 back. Down 2, 1 back. Okay. So, now, this is y is greater than. So when we graph this, is this going to be a solid or broken line? It's going to be broken. There we go. And where do we shade? Since y is greater than, we're going to shade above this line. So we're going to shade all above it. This is the solution. So just to double check, let's choose a point here. When x is 4, y and y is 1, then is 1 greater than 2 times 4 plus 1? That's clearly not true. If y is 1 and x is 4, 2 times 4 is 8 plus 1 is 9. 1 is not greater than 9. However, if we choose a point here, when x is negative 4 and y is 2, then, 2, is 2 greater than when x is negative 4? 2 times negative 4 is negative 8 plus 1 is negative 7. That is true. So the true statement came from the shaded area, and the false statement came from the unshaded area. This is the graph of our line. Graph the inequality y is less than or equal to negative x plus 3. See how easy I'm making these for you? This is already in slope-intercept form. We know our y-intercept is 3. So when x is 0, y is 3. And our slope is negative what? Negative 1, which when written as a fraction is negative 1 over 1. So that means we go down 1 and over 1, down 1 over 1, down 1 over 1. Or we go up 1, back 1, up 1, back 1, up 1, back 1. And I'm going to stop there and I'm going to just graph this line. And it's solid because can our solutions, or does our solution set include the points on this line? Yes, it does, because y can be less than or equal to that line, the points on that line. So, where do we shade? Y is less than this line, so we're going to shade on the bottom side, so all over here. Don't you like my shading? Yay. All right. And here we go. Okay, and just to double check, let's choose 2 points. One over here. All right, so when y is negative, what is that? I can't read my own hand. Negative 2 and then y is 3. So if y is 3 less than or equal to negative, negative x, which is negative 2 plus 3. 3 is less than or equal to negative 2 is positive 2. 2 plus 3 is 5. 3 indeed is less than or equal to 5. Now let's choose a point over here. Let's say x is 4 and y is 4. Well, that's clearly not true. Y is less than or equal to when x is 4, negative x is negative 4. And negative 4 plus 3 is negative 1. Is 4 less than or equal to negative 1? No, that's a false statement. So again, the true statement came from the solution set, and the false statement came from outside of the solution set. Now, number 10 asks you to graph the system of inequalities, and notice what I did here. You may find this on your test. I'm trying to make it as easy as possible. These are the 2 lines you just graphed. So go and look at your lines and say, oh, okay, I'm going to graph this line. When our y-intercept is 1, our slope is 2, down 2 over 1. All right, that's broken. So I'm going to make that broken. And I'm going to leave this b for now. And I'm going to graph this line. Y is less than or equal to negative x plus 3. So negative x plus 3. Y-intercept is 3. Our slope is negative, so it goes down this way. Our x-intercept is actually going to be 3 also. So let me just graph a solid line here. Now there's two ways of doing this. We talked about both ways. You could, let me graph a better line. I wonder if I can put a ruler on this pad that I use to do this. Okay. So now, you can either do this in your head or keep track of what areas are shaded, or you could actually shade the whole thing and make one of the regions darker. So this is an easy way that I like to do it. Whenever two lines intersect, there are 4 regions that are created. Now it's important, forget about these, the x and y axis right now. We're only thinking about these 2 lines. We've got this region over here, this region over here, this region over here, and this region over here. And let's keep track of how many times we shade each region. So for this first line, y is greater than 2x plus 1. Remember, that was this line over here. We're going to shade everything above this line. So look at our original graph, everything above this line. So of these 4 regions, which ones are going to be graph, or which ones are going to be shaded? If we're shading above this line, we're going to shade this region, and we're going to shade this region, right? Everything above this line. Now, when we graph y is less than or equal to negative x plus 3, our graph looked like this. Y is less than or equal to that line, so we're going to shade below that line. So we're going to take this line and we're going to shade everything below it. So we're shading which of these regions? Well, we're shading this region, but we're also shading this region, right? Now, which one of these regions was shaded more than one time? This one, right? So this region is both as a part of the solution of this inequality and of this inequality. So this is the overlapping region. So what do we shade? We shade that. And let's use a fun color. Let's use bright red. And so our solution looks like this. Oops. Uh-oh, I went outside the lines. I fail kindergarten. And there we go. That's our solution. And as always, you should always double check your solution if you can read it. Here's a point inside the solution. When x is negative 2 and y is 2, should that be true? So let's look at the first one. If y is 2 and x is negative 2 times 2 is negative 4 plus 1 is negative 3. And 2 is greater than negative 3. If y is 2, is that less than or equal to when x is... uh-oh, what did I do? Did I say y is... Was it 2? Oh, it doesn't matter. That's still in the region. Okay, I solved... let me do that again. Okay, if x is negative 2 and y is 2, that should be the point. There we go. If y is 2, is that true... is this inequality true when x is negative 2? And then that gives us negative 3, and that's true. All right, when y is 2, is that less than or equal to when x is negative 2? What is negative 2? That's positive 2, plus 3 is 5. 2 is less than or equal to 5. And let's take a, well, I'm not going to go through the trouble. This is the right solution. So you can take any points over here, and you can plug those into both inequalities, and you'll see that none of those work out. Those all give you false statements, in at least one of these inequalities. It'll be, for example, this point will be true in this first inequality, but it won't be true in this second. This point I don't think will be true in either of them. No. And this point will be true in the second inequality and not this first. So by this point, you should have you should have a score out of 10. If you are having any trouble or you want me to repost some or post some more examples of any types of these problems, I will. Please email me by, I guess, Sunday at 12, and I'll try to have it up by Sunday at 5 so you can do some last minute studying. Good luck. I know you're all going to do a fantastic job.